Hi there, guys. Well, welcome back. We're about to do exercises 2P and 2O. And I lied a little bit about what's coming up next because I was only just looking briefly down at the title for the next one. It says function transformations. I figured that would be a little bit of your normal function transformations. You know, when we're saying what happens to f of x when we take it to, I don't know, f of x minus a. What happens when you do a of f of x, and so on. You know, so you know the transformations, and you know we can put one on the end. We could say f of x plus a, and we can do the other one. What's missing there? F of ax 1 over ax, however you want to put it down. And you can play around with those. You can see what happens to those. But actually, this is not about that. You may be interested in that. So hopefully you're interested in these things. You know, you are an HL mathematics student. So, okay, so if I wanted to put in f of x, let's just come up with a function here. Let's say, let's take an easy one, x squared. What happens when we do x minus 1? Well, there you go. It's pushing it forwards 1. What happens when you do minus 1 on the end? Okay, done that before. And what happens when you change the function to 2 lots of f of x? Doubles all of the heights. And the less obvious one with this is what happens when, let's choose a different function for this one. Let's choose sine of x, for example. What happens when we put a 2 in front of that? Well, it doubles the frequency, but it actually compresses the function. It's a stretch by a factor of a half in the x direction, or a squash by a factor of 2, but we don't say that. So stretch by a factor of a half if you put that in there. So it's always the reverse of what happens on the inside. And because this exercise is not really about this, what's difficult on this is, I'll just leave you with this thought, is how on earth do you explain this one? You know, when you say, well, let's take away 1 there and let's times by 2. How do you explain that? Which way around is that? Is that a movement by 1 and then a stretch in? Or is that a stretch in and then taking it forward by 1? I'm not going to say that because that's actually a tricky point to explain. But, you know, you should know because that comes from previous courses. Okay, anyway, that's not what this exercise is about. This exercise is actually about transforming using the modulus sign. Okay, so I've taken this one, taken this one here, come on, take this one here. So it's just giving us a little definition, and actually this one's pretty easy to deal with graphically, but it's saying that if you take the modulus of a function, then anything which is above the function doesn't get changed. Above the x-axis doesn't change. You know, so if we take this, we take the modulus of this function. This is good because it gives you positive answers. This is not good, so we'll need to replace that by this thing here. Okay, and this is good again. And that's essentially what it's saying here. It says the graph is unchanged for when y is greater than 0. That's y equals to 0. And it's reflected in the x-axis for the other parts, which is exactly what I've done here. And then on this one, it says, what happens if you do f of the modulus of x? How is that different? Can you just bring these things inside? Is that the same thing? Well, no, it's not the same thing. Let's take an example. Take that sine of x again, which we had a moment ago. Okay, and let's take this. Of course, it goes on forever. This is 360 degrees, or 2 pi. And this is a height of 1, and this is a height of minus 1. And they should be, this is an odd function. So there should be rotational symmetry about 0, 0 of 180 degrees. Okay, or rotational symmetry order 2, perhaps you could say. But yeah, you could rotate this 180 degrees about 0, 0. Okay, so the graph is unchanged when x is greater than or equal to 0. So basically, if I put in sine of 90 degrees, be here. Okay, so sine of 90 degrees is the same as sine of the modulus of 90 degrees. Likewise, if I choose 270 degrees, giving me an answer of -1. Okay, so let's take this back. Choose 270 degrees, and that's the same as doing sine of the modulus of 270 because the number's not changing there. So nothing on the right-hand side is changing. That's all just stays the same. And that's what they say. It remains unchanged when on this side of the y-axis, when y-axis, of course, being equals to 0. Okay, so what's happening on the other side? Well, you know, if you put in, say, the sine of, let's take -90, put it in that modulus sign, that's going to give us sine of 90. It means to say that this, let's choose color, let's say this point here is sine of 90 degrees, and we're now plotting it when we put in -90. So that point is now going to be plotted over here. So when we put in -90, we end up getting out the same answer we got on the right-hand side. And that happens, of course, for all of these. So you're going to end up getting a reflection of this thing. There we go. A reflection of this thing here on this side. Okay, looking a bit like a moustache there. Okay, so so basically, what's happening is this whole left-hand side is getting wiped out. Essentially, you can't put in any negative numbers anymore. You don't really know what was happening with the negative numbers because that's all lost. So the function of the negative numbers is completely lost because we can't put in negative numbers anymore. So all of this is lost, and we just have everything on this side repeated on the other side. Okay, pretty simple idea, really. So there's only one question on this. Let's just take this one. That's why we're going to do the next exercise as well here. So example 30, from the graph y equals x cubed minus 4x, sketch these graphs. So we can see there's the original graph. By giving you that, we're saying sketch this one and sketch this one here. So of course this is really f of x with the modulus brackets around it, and this is really f of modulus of x. So for the first one, let's choose green for this one. So for this one here, we're going to adjust that's good, and everything else is going to go like that. So it's going to look like this, like that. Okay. So everything negative is going to be shifted upwards. Okay. So that's the first one. And for the second one, let's do this in magenta. And the second one, everything on the left-hand side is going to get wiped out and replaced with a copy of what's on the right-hand side. So this thing is on the right-hand side. So that's the completion of this one here. Okay, hopefully that one's pretty clear. Everything on the left-hand side gets wiped out and it gets replaced by a copy of what's on the right-hand side of this graph. Okay, well that's that done. And there's 2 O's, obviously get some decent practice on that. And then they talk about reciprocal functions, and instead of doing the investigation, which as ever is always good, and actually instead of looking at this box, because I think there's just a lot of words here, and it's actually easy enough to do through an example, we're going to do this through the example. So this is now talking about, what we call it anything. So it's just still transformation of functions then. So let's take example 31. Here we go. It says you can use a calculator for this as well, which is nice. It says draw the graph of y equals x and x minus 4. And on the same set of axes, sketch the graph of its reciprocal. Reciprocal being 1 over this function. Okay. Actually, I think you can do this without a calculator. Y equals x minus 4, it's a pretty straightforward function, has roots at 0 and 4, and it goes down to, so something like this. And I know that this middle point is when I put in 2, is 2 minus 4 there is 2 times minus 2 is minus 4. So my turning point is minus 4 and 2, and I've got 0 and 4 there, and this I should say is x and this is y. So that's my original function, pretty straightforward to draw. Now we need to draw this one here, and so to draw that we just need to think about what we're doing 1 divided by. So let's think that to start off with, we can't obviously divide by a 0. So we've got a 0 here and a 0 here. Now, since we can't divide by 0, I'm going to put on here an asymptote here, and we'll put an asymptote here as well. I'm not allowed to divide by 0. So by doing 1 divided by 0, and 0 comes about by me putting in 0 or 4, I get non-defined answers. Now, if I do 1 divided by 1, that's the other key case. So where's 1? It's like there. And then also we've got minus 1 sort of here as well. Now remember, if you do 1 divided by 1, then we're definitely going to go through that point, because 1 divided by 1 is 1. And that's going to be this point over here as well. Okay, so those points are 1, comma, not 1, comma, there's something, comma, 1. Okay, and when you get negative 1, let's think about what happens there. If you do 1 divided by negative 1, that's also going to give you the answer of minus 1. So on our new graph, 1 divided by minus 1, that's a height of minus 1. So what we're doing essentially is putting minus 1 in the bottom here. So where do we get a minus 1? We get it here. So 1 divided by minus 1 is still there. Okay, so we're going to put those ones in. That's the points where we get something, comma, minus 1. And all I've done is I've got those from taking a height of minus 1 there. Okay, and then we can kind of think about how this has got to go. So I wish I'd made this bigger, but when we divide by really big numbers, 1 divided by really big numbers becomes small really quickly. So we know that this is going to become small here. This is going to tend to 0. And I also know that this is going to tend towards infinity. And because I know that I'm dividing by positive numbers this side, I know it's got to be positive infinity. So let's try and put this one in. We've got that there. That's meant to be tending towards. Okay, definitely not touching this line, but definitely not curving backwards this way as well. It's quite difficult to draw correctly for the examiner, because this definitely shouldn't touch. Otherwise, you're showing that you can touch an asymptote, and it definitely doesn't come back this way, because otherwise it's not a function. Okay, so it would be a one-to-many graph. So don't do that. Don't make a C, because you will lose marks. You need to be careful on this. Now, the same is going to happen on this side. And, I'm sorry if I'm not that careful. It's pretty difficult to draw on my screen like this. So again, it shouldn't touch. That shouldn't be touching that asymptote. And it shouldn't be touching the y-axis, and it kind of is there. So it shouldn't be. And then here, of course, when we divide by minus 4, you get minus a quarter. Okay, so that point, let's actually call that something, because the whole thing is getting incredibly messy. So that point is actually 2, minus a quarter. Okay, because we've just divided by the height of minus 4 there. So then in the middle, we can then put in, join these two up. It's going to join up with a curve. And then, of course, dividing by very small numbers. So when we're dividing by very small negative numbers, that's going to give us 1 divided by something incredibly small, or divided by something small, becomes incredibly large. For example, 1 divided by 0 minus 0.1 gives us minus 10. Okay, so this is going to get large very quickly in a negative sense. So we're going down like this, and we're going down like this. Okay, and again, this shouldn't be going backwards. It looks like it's going backwards a bit there, and it shouldn't. Okay, so key points for this then. So key points I would say is, first of all, find your asymptotes. So find those, that's number one. Secondly, find when you have your heights of 1, because that's going to give you the same height of 1. And also find where you have a height of -1, because that's going to give you a height of -1 as well. And then you need to think about putting in any, they call them extrema here. We're talking about minimum turning points, maximum turning points, basically. So finding any extrema, quite like that word, I don't normally use it myself. Finding any extreme points, basically. So looking at any particular interesting points. So we're talking about minimum or maximum turning points. And then your final step is to, put in your sketch. So complete the graph. Okay, well, that's how it should be. Let's actually draw this one out in Desmos. Okay, so doesn't like me doing that. Let's put in f of x is equal to 1 divided by x times by x minus 4. There we go, we can get rid of that original bracket now. And there we go, we can see that that is our graph. And we can see there's our point. Our point is 2, minus a quarter. And you can see that the shape of this actually tends towards these asymptotes extremely quickly. We can put in our asymptotes here, say x is equal to 0. And we've got x is equal to, I don't know if we can write x is equal to 4 there. No, it doesn't like it. If we write it on one line, say x is equal to 4 as our other asymptote. And now when you put them on your line, you'll put them on as dotted lines. Okay, and also you put the equations of those on the line. So make sure that you've answered the question here. It does say label any intercepts. Did I forget to do that? No, I found all the intercepts. We found the zeros. There were only 2 zeros. The 2 zeros were here and here for the original function, but there were no zeros for the reciprocal function which we took there. And the extrema we've noted down as a coordinate point, and the asymptotes have been defined. They've been defined to the side. The vertical asymptotes are x is equal to 0 and x is equal to 4. Oh, I've forgotten something. With the asymptotes, I've forgotten something, and it's the horizontal asymptote. Okay, so there is a horizontal asymptote. If we look at this graph here, we can see, let's just put this in, we can see that this tends to 0 and this tends to 0 here as well. It doesn't tend to 0 in the center here, but it does to either side. So for this graph, for our reciprocal function, it does tend to 0. So we have an asymptote as we tend to negative infinity and positive infinity. Let's just see how they write that down. They say it has 1 over f has an horizontal asymptote at y equals 0. That's all they've stated. Yeah, okay. Right, that takes you to 2p, and there are your questions. Only 2 of the questions there, so make sure you're getting some decent practice. And let's have a look at what's coming up next. Coming up next appears to be odd and even functions and reflections. Okay, so that's what's coming up next. Okay, thanks for listening, and I'll see you for the next one.